Imagine a realm of perfect balance. Planets orbiting a radiant star, each following a measured path through the vast emptiness. For billions of years, our solar system has held its own fragile harmony, a jewel of order in a chaotic universe. Yet this stability is not guaranteed. Far beyond our sun's influence, hidden in the cosmic darkness, lurk ancient objects, remnants of creation's earliest moments. Among these relics are primordial black holes, silent and invisible. If one were to enter our solar system, that fragile harmony could shatter in an instant. Most black holes form when massive stars die, collapsing under their own gravity to create regions so dense that nothing, not even light, escapes. But primordial black holes are different. They emerged in the turbulent fractions of a second after the Big Bang. Back then, the newborn universe was a cauldron of unimaginable heat and density, with quantum fluctuations causing tiny pockets of matter to compress far beyond any star's collapse. Some of these fluctuations were so intense that they produced black holes directly, no stars required. These black holes, formed before galaxies coalesced or stars ignited, are among the oldest objects in existence. Their sizes could vary dramatically. Some might be as light as a mountain, others as heavy as millions of suns. Many might have evaporated over cosmic eons due to a strange quantum effect known as Hawking radiation. Those that remain are survivors of an era we can barely comprehend. They drift through the galaxy, cold and dark, leaving only subtle gravitational fingerprints as evidence of their passage. Now consider one such primordial black hole drifting through interstellar space. Its path, random and indifferent, brings it nearer to our region of the galaxy. At first, we wouldn't notice. It emits no light, no heat, no telltale signals. Even if it were the size of a small asteroid, its mass could rival a planet's, and its gravitational pull would be immense. Slowly, it would approach the outer boundary of our solar system, the distant realms of comets and icy debris. As it moves inward, subtle changes begin. Tiny gravitational nudges might dislodge comets from their delicate orbits, sending them swirling toward the inner solar system. At this early stage, astronomers, if vigilant and fortunate, might detect anomalies. Maybe a distant spacecraft's trajectory shifts by a fraction of a degree. Maybe starlight behind the black hole bends strangely, producing a brief brightening known as gravitational lensing. These could be the first whispers of impending disaster. As the primordial black hole ventures deeper, its gravity would upset the gravitational tapestry woven by the sun and planets over billions of years. Even a slight perturbation could alter planetary orbits. For Earth, this might mean drifting closer or farther from the sun, changing our climate drastically. A slip into a cooler orbit could trigger a prolonged ice age. Moving nearer might parch continents and bake oceans into steam. Further out, the gravitational chaos would be profound. The Kuiper Belt, a realm of icy bodies beyond Neptune, could be scattered like marbles spilled from a bowl. These displaced chunks of ice and rock might hurtle inward, risking catastrophic collisions with inhabited worlds. The asteroid belt, usually stable, could be flung into chaos as well, bombarding inner planets with relentless impacts. The solar system would cease to be the orderly clockwork we have come to rely on. Instead, it would become a place of shifting orbits and altered destinies, ruled by the black hole's silent presence. If the black hole ventured even closer, tantalizingly near a planet, it could exert immense tidal forces. Consider the unimaginable stresses placed on Earth. The side facing the black hole would experience a gravitational tug far stronger than the side facing away. Our planet could be stretched, its crust cracking open. Volcanoes might erupt en masse, releasing clouds of ash that blot out the sun. Earthquakes of unprecedented magnitude would shatter cities. Tidal waves would wash across continents. Even the moon, which stabilizes our climate, might be tugged from its orbit, compounding the chaos. For gas giants like Jupiter or Saturn, the black hole's approach could rip apart their retinues of moons, transforming them into belts of rubble. In extreme cases, parts of these planets' atmospheres might be siphoned off, adding eerie glowing accretion streams around the black hole. In a matter of days or weeks, the solar system could be transformed into a war zone of colliding asteroids, erupting worlds, and extreme climate shifts, all orchestrated by an invisible, silent intruder. Some primordial black holes, especially smaller ones, might be in their final stages of life. According to Stephen Hawking's theory, black holes slowly evaporate, emitting what is now called Hawking radiation. This radiation would be minuscule for large black holes, but as a black hole shrinks, the intensity of its radiation rises dramatically. If a dying primordial black hole reached the solar system and then erupted in a final burst of gamma rays, as it evaporated, it could flood nearby space with lethal radiation. Earth's protective atmosphere might be stripped of its ozone layer. Life would face a barrage of ultraviolet light. Ecosystems, already on the brink from climate upheaval, would be pushed toward collapse. But the worst scenario might unfold if the black hole came close to the Sun. The Sun, the source of Earth's warmth and stability, could feed the black hole's event horizon with streams of plasma. As matter swirled around it, the black hole would form a superheated accretion disk, emitting X-rays and other high-energy photons. This sudden surge of energy might disrupt the Sun's magnetic fields, provoking immense solar flares and coronal mass ejections that could roast Earth's surface and fry satellite electronics. Our star, so long a benign caretaker, could become a wild, dangerous entity, lashing out unpredictably. Could we detect and prepare for such an event? Detection would be challenging. Primordial black holes emit no light of their own. They reveal themselves only by gravitational influence. Advanced telescopes might catch gravitational lensing events, brief distortions of distant starlight. Subtle orbital anomalies of distant space probes could hint at an unseen mass. Gravitational wave observatories could potentially pick up signals if the black hole were to merge with another compact object. Such observations might provide a warning, perhaps a few months, maybe years, before the visitor arrived. If scientists identified a primordial black hole heading our way, what could we do? Realistically, with current technology, diverting or destroying it would be impossible. Unlike asteroids, which we can potentially push off course, a black hole's gravitational pull is unyielding. We might at best hope to predict its trajectory, brace for atmospheric effects, and safeguard critical infrastructure. Preparedness might mean hardening power grids, preserving data, and planning for catastrophic climate shifts. Survival would hinge on knowledge, resilience, and luck. Thankfully, the odds of a primordial black hole entering our solar system are vanishingly small. The galaxy is vast, and black holes are relatively rare. Primordial black holes, if they still exist in large numbers, are scattered like needles in a cosmic haystack. Our solar system, a minuscule target in a huge galaxy, is unlikely to encounter such a threat. Yet the low probability does not erase the possibility entirely. Studying this scenario highlights the fragility of our cosmic home. We take for granted that Earth's orbit is stable, that the planets remain where they are, and that tomorrow's sunrise is guaranteed. But on cosmic timescales, even our solar system's neat arrangement could be upended by an unexpected visitor. The hunt for primordial black holes is not just about anticipating doomsday scenarios. These objects hold clues to the earliest eras of the universe. If we find evidence of them, we learn about conditions fractions of a second after the Big Bang, conditions we cannot replicate in any laboratory. Understanding primordial black holes might also help solve the mystery of dark matter. Some researchers speculate that a population of small, ancient black holes could account for some or all of the invisible mass holding galaxies together. If primordial black holes contribute to dark matter, then in a sense, they form the hidden backbone of the cosmos. Their gravitational influence would have shaped galaxy formation and evolution. Identifying them would rewrite our understanding of the universe's structure and history. The universe has no agenda. It is neither malicious nor benevolent. Events such as a primordial black hole entering our solar system are natural occurrences on grand timescales. That we exist in a peaceful corner of space, enjoying relative stability, is a cosmic accident, one we should cherish and not assume permanent. The idea that a primordial black hole could wander through our cosmic neighborhood might seem like pure speculation, and in a sense, it is. Yet it underscores how much remains beyond our control. We are vulnerable creatures living on a delicate world, reliant on celestial alignments that could be disrupted by forces beyond imagination. While we can do little to prevent such an event with current technology, contemplating it drives us to broaden our horizons. We develop better telescopes and gravitational wave detectors, refine our models of cosmic evolution, and invest in space missions that help us monitor the outer solar system. The quest to understand the universe is, at its core, a survival strategy. By knowing what is out there, we gain a measure of foresight, and perhaps, one distant day, the means to protect ourselves. This scenario also prompts deeper philosophical reflections. If we discovered a black hole approaching, how would we respond as a species? Would we come together, sharing resources and knowledge to preserve civilization? Or would fear and disorder prevail? The threat of a primordial black hole is a reminder that we are part of a cosmic ecosystem, subject to cosmic forces far greater than any human endeavor. The primordial black hole is the ultimate cosmic wildcard, an ancient enigma drifting through the darkness, forged when time was young. The threat is remote, yet its lesson is clear. We must remain vigilant, curious, and united in the face of the unknown.